Hello everyone. So I hope you followed my previous video on the previous example when we generated the object program for the given SIC program. So in the today's video, so let us take up this as the source program which is given here, for which let us try to generate the object program. So here you can also observe the opcodes for the respective instructions, respective mnemonic symbols it is given, right? Let us start generating the first. Let us start assigning the addresses for all the instructions. So from the starting address, so as for this example, this is the starting address, which is 4512, from where I supposed to start assigning the address. And definitely I don't have to assign any address for the first instruction, which is start instruction. So this address will be 4512 itself. And again, I mentioned the previous example also, you need to categorize the instructions as which are all the assembly directive instruction and which are non-assembly directive instruction. So here you have the assembly directive instruction, and these are all the non-assembly directive instruction. And for the non-assembly directive instruction, we have a standard format in SIC, and this is the standard format in SIC, which has opcode of 8 bits followed by X of 1 bit, and again operand address it is of 15 bits, so totally 24 bits. So 24 bits mean nothing else than the 3 bytes. So those are the 3 bytes where we are supposed to assign for every non-assembly directive instructions. So in that means, so you just start assigning the 3 bytes for all these instructions. In that perspective, so this will become 4515, again 4518, again 4518 plus 3 is 11. 8 plus 3 is 11. 11 is nothing as B. Again 451, 11 plus 3 it is 14. 14 is nothing as 1 E, right? Followed by 14 plus 3 is 17. So you'll get 4521, right? Is 17. Again 4524. Again 4527, right? Again 452A. And now you got assembly directive instruction, and as this is the byte instruction, I hope you remembered from my previous example I have quoted that. So for the word instruction, okay, for word instruction you will be assigning the three bytes irrespective of the operand, whereas for the byte instructions you have to assign the byte you need to assign the memory space purely based on the length of the operand. Here the length of the operand is, you can observe there are two hexadecimal number. It is x for representing hexadecimal number, and how many hexadecimal number? There are two hexadecimal numbers are there, which is f and the 1. And as there are two hexadecimal numbers, which is the f and the 1, so each hexadecimal number, I repeat, for each hexadecimal number it requires half byte. So as there are two hexadecimal numbers, which is the f and the 1, so for the two hexadecimal numbers it requires 1 byte. So the next address would be 452B. Again here same way, byte x05. So there are two hexadecimal numbers, which is 05, and for which you need one more byte, so it will be 452C. Then here it is data reserve byte 1. Even in our previous example also we have considered reserve word case, where you need to allocate the memory space based on the operand. Here the operand is 1, so it is reserve byte 1. It means to say that where you will be allocating a 1 byte. So when you allocate 1 byte, so it will become 452 and D. So that's the last address for the particular program. Now let us start generating the object codes. So when you take up the first instruction, which is TD indiv, what is the opcode of TD? So it is E0. So E and 0. That's the 8-bit representation for the E0. Then followed by, as I mentioned in the previous example also, you need to categorize whether the so-and-so instruction belongs to indexing addressing mode or direct addressing mode. It is based on the utilization of X bit. So here, if you are using any X register in the operand fields, then such instruction will belongs to the indexing addressing mode. Here you can observe all these in all these operands you are not using any index register, so for all these X will be definitely 0. Then followed by operand address. What is the operand here? It is indiv. Indiv is operand. What is the address of that indiv? It is 452A. I repeat, it is 452A. How to write that 452A in the bits form? So it is 452 00102 and 1010 is A. But when you write 452A in the bit representation, it requires 16 bits. But however, our operand address field is of only 15 bits. So definitely, even I mentioned in the previous example also, you need to neglect the first bit, irrespective whether it is a 0 or 1. You have to neglect the first bit to make it as a 15 bits to fit into the 15-bit field. Okay, the first bit is irrespective of 0 or the 1, so you have to neglect that. Now again form a group every 4 bits together. When you group 4 bits together, first 4 bits it is what? E0. Again including this 0 and 100, you have to include this 1 bit and the 3 bits, so totally 4 bits. So it is E0 followed by 0 0 and 00, which is 4 5 2 and the A. That's the object code for the first instruction. Next instruction is what? JEQ. What is opcode of JEQ? It is 30. So 0011 and 0. 30, again it's not using any X register. It is not using any X register in the operand field, followed by in loop. What is the address of in loop? You can find out here. It is 4512. But how to write 4? It is 100. It is not 0100. It is just a 100 and 5 0101 1001 and 0010 is 2. So based on this, what is the object code you got? It is 304512. Right. Next we have RD. What is the opcode of RD? It is D8. How to write? 1101 is D and 1000 is 8. Again, is not using X register. And what is the operand here? It is the indiv. What is the address of the indiv? It is 452A. So it is 1004 and 010 is 5, 0010 is 2 and 1010 is A. So based on that, what is the object code you got? It is D8452A. That's the object code for you, right? Next, STCH. What is the opcode of STCH? It is 54. So I'll say 01015 and 01004. No usage of X register, followed by. So what is the operand here? It is the data. What is the address of the data? Here it is 452C. So how to write 4? 4500102 and C. How to write C? 0000 is C. So based on which, what is the object code you got? 54452 and the C. Again, next instruction, which is TD. What is the opcode of TD? It is E0. 1110 and 4 zeros. No usage of X register. Again, out D. What is the address of out D? It is 452B. 4500102 and the B. How to write B? It is 1011. Right. Based on that, what is the object code you got? It is E0452B. That's the object code for you. Right. Next we have JEQ outloop. What is the opcode of JEQ? You can observe, yeah, 30. Right. 0011 and 4 zeros. Again, X register is as usual 0, followed by the operand address. What is the operand here? It is outloop. What is the address of that outloop? It is 451E. So 451 and E. Right. So based on which, what is the object code? First 4 bits we need group 3 0 4 5 1 and E. That's the object code for the current instruction. Next, LDCH data. What is the opcode of LDCH? What is the opcode of LDCH? It is 50. So 50. No usage of X register. Again, LDCH data, right? What is the operand here? It is data. What is the address of data? It is 452C. 452 and C. So based on this, what is the object code you got? It is 50, right? 50452C. Done. Next you have WD. What is the opcode of WD? It is DC. How to write D? 1101 is D, 1100 is C. No usage of X register. Again, what is the operand? It is out D. What is the address of out D? Here it is 452B. 4 5 and 2 0010 and B is what? 1011. So based on this, what is the object code you got? It is DC 452B. Right. That's how we generated the object code for the non-assembly directory instructions based on the based on this format. Now let us get into the assembly directory instructions. Remember, even we have spoke about this in the previous example also. For the word and the instruction, your operand itself will act as a object code. Here the what is operand here is F1. That F1 itself will act as the object code. The same way 05 itself will act as object code. Even I hope you remembered, for these only we assigned one byte, only one byte to each. So in that one byte F1 will be stored. In the for that next address, next one byte you will be storing 05. When it comes to 0 byte, as we spoke about this in the previous example also, there is no object code for the reserve byte and reserve word instructions, because it's only just a means of memory assignment. You will be leaving an empty space, that's it. So no need of any memory, no need of any generation of object code, right? In that way we are done with the object code generation also. Now let me take you to the object program, writing the object program. So in that first header record, H followed by name of the program. What is the name of the program? Here it is input, followed by, see, basically 2 to 7 is the name of the program, but here it is, you can observe 2, 3, 4, 5, 6 only, and one space you have to leave. So that's what name of the program. Starting address 004512, followed by length of the program. How to find out the length of the program? It's so simple. You just need to find out such a way that in the hexadecimal last address is what? 452D minus 4512. Last address minus first address. When you subtract, what you are getting as 1B. So that's the length of the program. So 4 zeros 1B. That's the text. So you are done with the header record. Now let's start with the text record. When we start with the text record, where is the first object code? First object code is here. What is the address of that? It is 4512. So I'll say 004512. That is where the first text record is starting. And next, length, let me leave it as space. Okay, let me leave the space. Then you just keep writing the, okay, you keep filling the object codes like this. You just need to keep filling the object codes, but while filling you should also keep counting, because you can have only maximum of 69 columns in the text record, not more than that 69. I repeat, you can only have up to 69 columns in the particular text record, not more than 69. It should not exceed that. You have to make sure about it, then only you can, if you try to, like, in any text record, if it exceeds 69 or if it is about to exceed 69, you have to stop that text record. You need to initiate the new text record, because it's your maximum capacity of your stone to text record, it is of only 69 only. Keep that in mind, right? So now I'm just writing right now. I'll also show you how to count as well. Okay, like that I have written. But for your information, see, this is the this is the structure of the text record what we have. So it is 10 to 69. So 1 is T, followed by 2 to 7 starting address, 8 to 9 is length, and 10 to 69 is the actual object codes. So how to count? So if you want, you can count like this. You can observe, see, 1 T, again 2 to 7 is the length, sorry, starting address, 8 9 is length, we have left space. I'll come to that later. Then later you can keep counting 10, 11, 12, 13, 14, 15, 16. So till here it is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58. So it is not exceeding 69. So it means to say that all that object codes in the given program can fit into the single text record. Then find out the length. How to find out the length? See, this is what 3 bytes. I hope you know that. It's 3 bytes. 3 plus 3 6 plus 3 9, 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, 18 plus 3 22, 22 plus 3 25, 25 plus 1 26, 26 plus 1 is 27 bytes. I repeat, 27 bytes. But in the hexadecimal, so it is 27 in the means. So in the hexadecimal, how much? In the decimal 27, in the hexadecimal, how much? You need to calculate. So before you can do it, so if you want me to tell you again how to find out, see, this is every 2 hexadecimal numbers is 1 byte. So to 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. So totally 26 bytes. So in that decimal it is 26, means in the hexadecimal it is 1a, right? So the length of this text record is 1a. Done. So you are done with the text record as well. Now so next record is e followed by the starting address. What is starting address? Is 004512. So this is the object program for this given source program. So what we did, we assigned the addresses, then we generated the object code, and we have written the object program as well, right? Thank you.